All right, we're COMP1004, and it's fall 2016 semester at Georgian, and it's week 4, part 3 of our broadcast. For those people who have been watching, obviously my window's updated, right? Was updating at the same time, and it's still not done. We're still at 53%. So obviously I can't continue with that right now, but hopefully we'll be able to get there and fix it later on. Okay, so PowerPoint. What I was going to demonstrate for you guys was the ability for you to extract a method from a have a bunch of code in my click event. It doesn't make sense that I'd have all this code in my click event. It doesn't make sense at all. I'd rather just have a method call in it or two as opposed to a bunch of code. So I'd rather make another method, and I can extract my method. Extract my method by doing control dot and then select extract method from the quick actions menu. Or what I can also do is click on the menu, and I can't show you right now because Visual Studio is down. But you can go to edit, and if you go to refactor extract method, it'll do the same thing. Okay. Here's something that's interesting. Reference parameters. Okay. Why the heck would we want to use reference parameters, right? And what are they anyway? Reference parameters are like, who's ever done C++? Yeah? Anyone else do C? Like C, classic C. Okay, we guys, oh wow, I'm really impressed. That's almost like, I never get that, people doing that. So if you've done C++ or classic C, a lot of times we can use something called pointers, right? And pointers are really references to an address location, right? That's if you think about it, if you boil it all down to what it's supposed to be, right? And I have a pointer to the variable. I have another construct, this pointer, that literally points to the address of the variable. So when I have the pointer can act as if it is the variable in different ways, right? Well, so too are ref and out. I can use the ref and out keywords to act as if they're pointers, but out, maybe is a little bit more, I'm going to put it out there to you guys, useful than ref. Okay, I'll talk about what ref is. So ref actually creates a reference. So it's a call by reference as opposed to a call by value. Every time you pass something to a method, it's called by value. So I pass it in, and then when it's inside the method, it's now inside of the method scope, and it doesn't leave the method scope. But if I use the ref keyword, I got to do it in two places. When I create the variable, so when I create my passes by reference, so I don't have to, whatever I change inside my method gets changed outside as well. Now you might think this is bad, and it's not stable. In fact, if anything, it's bad coding, right? It's not. You don't want to use ref unless you want to kind of figure out a problem, and you're trying to do a workaround, and you want to use ref to solve your problem temporarily. Typically, we don't want to do it that way. Okay. However, I got to point out that whenever we pass an object to a method, you're calling by reference anyway, right? There are basic objects show your default data types. For example, things like double and int and float and those kinds of data types. If you pass them into a method, it's called by value, right? You're copying the data and creating another variable that's only living and dying in the method, and then you're dealing with that data, right? Whereas if I pass in something like an array, right? Does it make a new array? No, it doesn't, actually. What it does, if you think about it, it creates a reference to the old array. You gotta be careful what you do and how it's done, right? So sometimes, or if I pass in an object, like let's say I listened for an object let's say, for example, I'm building a deck of cards, and I have an object that I built, and I like to use the deck of cards example. I build an object, a class, that's the card class. Okay, let's build a card class in my head here for a second. So if I was going to code the card class, I would have two properties of my card class. So each card would have a face, right? The face of the card, and the value, face and value, right? So now that I have my card class, I want to create a deck. A deck would be a list of cards, right? So the very simplest deck would be, I have a list, and I add, the type of list is the card list. That's what it is, right? And I'm adding in cards to the list. right? Okay, great. So now I have my deck of cards, and it's a list type. A list is a reference type. That list off to a list. I'm not passing by value. I'm passing by reference because it's a complex type. So too, you can do the same thing with ref. What about out though? Out is totally something different, right? What out does is you can with an out parameter. What you're doing is you'll of the return, right? So whatever we return back from, you know, the method is returned inside the out parameter. Okay, what do I mean by that? So it kind of stores it. It's like the same idea, right, of like a reference, but the other way around. It's almost like where it returns the value, right? As opposed to returning the value to a particular object, it returns the value to an object a lot in Unity, especially when we do things like, I was putting it out there, especially when we do things like line casting, right? The out parameter is used so that way we can do things like return, and for you people who don't know what line casting, think about me casting a line from an object to another object, and wherever it intersects with the other object, we have a collision. That's what we're doing, right? So we can detect things like, am I grounded when I create a character, you know, in a game, that kind of stuff. An example of that code. So if I said line casting without parameter, right? And if we did something with Unity answers, there's one. You can see that there are some. There are probably going to be some code examples of this. I'm trying to find. Here's one. So if my physics line cast, if it happens, if I hit, and as an example, I created a couple of new vectors, and notice that I have something called out with hit, and hit would be another variable. I'm telling where the output of my physics line cast method is going to go to the output to the hit parameter, a hit object which exists somewhere else. It's very interesting. It's a different way of returning values, right? So the actual, don't tell me I lost connectivity again. I love this room. I love this room. So it gives you some really cool examples. Again, this is C#. You told me you want to learn some Unity. Well, here's some Unity example script code from Unity. So what we want to do here when we use line casting is you can see that it gives you the type, and it gives you examples. We'll see if hopefully they have an example of an out, and they don't here. But typically we use out parameters to tell Visual Studio and C# where to put the data, okay, as opposed to return it to a variable, okay. So I'm trying to give you a good scenario for that. Again, is it very popular? No, it's rare that we use those kind of ref and out because it breaks that paradigm, okay, breaks the paradigm. So we don't want to do it, you know, very often, but it does solve problems. Okay, so there's refs and outs, and here's an example of the out parameter, the out keyword. Okay, I'm not going to go into that too much. All right, this is kind of boring. You've kind of understand the default or the custom event handler for a text box, right? So here's something. See this? This is interesting. This event handler is actually handled inside the designer, right? Where you actually have a so one part. There's two parts to the event handler, right? The event handler itself might be called something like, you know, clear future value, and you have, right? Backend on the design side. Remember, when you look at an object, you have a partial class for the form, and on the back side you have the designer. So there's three parts. There's the form view, the designer view. There's the code view, and then there's the designer code view, which is like the actual other part of the form we don't see. Well, this is where this happens. This is actually wiring up the event handler right here, right? And the way to do that is an example of, here's my text box. The text box in this particular case is called monthly investment text box. So the text change event, what you're going to do is you're going to add in plus equals a new event handler, which is based on the system event handler class, right? And you're going to call it this class that exists inside of our method called the clear future value event handler, which is right here. So that's how you would code it by hand if you wanted to. Am I going to get you guys to code it by hand on a test? No. But I want you to be able to see it and understand how to code an event handler by hand if you had to. And again, you would probably do this in the designer part of the event handler. Let's keep going. Yes.
By event handler, things like when or.
Yeah. So let's say I double click on a button, right? This part will appear. This part here. This is going to go inside the class that's inside the code behind file, right, of your form. This is where it's going to appear. But this one also happens, but it's in another part of your form, and it's called, if it has the keyword designer,
yeah,
right? That's where this part's going to appear, right?
So
and it's going to be hidden, right? So that way there's two parts. This part actually adds the event handler to your form itself.
So in other words, this is what we should create when I click buttons.
This happens automatically. Yeah, these two things happen automatically for you, right? And it gives you an example here. If you actually look at the form example, right? So we have the form itself. Here's the future value form. And if you look at it, we have this yearly interest rate and monthly investment. These are all the text boxes. And it's giving you an example of how you can point your text change event to a particular event handler. We've done that before. All right, so we can point events by clicking on this little lightning bolt. We can point our events to point at the same event or different events. And that's what I was going to do with the calculator. The calculator button, what I would do, and I was kind of hinting at what I would do, there's two approaches. One approach is all buttons, one event handler. So calculator buttons clicked event, right? So you make actually that event handler ahead of time, right? And what you can do is, and this is what I would do, I would double click on one button, make the event handler, rename it, right, to what I want, which would be the calculator button event handler, right? And then what I would do is I would take all of my buttons and point them to that event, okay? That's what I would do to make that custom or common event handler, if you will, or shared event handler. Okay, and this is what this thing is right here. It tells you in the forms designer that you can use the lightning bolt to kind of point to a specific event handler. So I'm not going to go into that too much, right? Because this is just repeating what we've already done. And it actually shows you the designer side. So here's the initialized component, and it tells you inside the designer.cs file where the button click event handler is going to go. It's good for you guys to understand this, right? Especially if you want to wire up your own custom event handler without having to click the lightning bolt, or if you want to fix a problem with your design. Sometimes what happens is you remove the event handler by accident, by hand, and all of a sudden now you can't see your design anymore. So the way to fix that is to delete this line. So it's looking for this, but it doesn't exist, and that's why the design doesn't come up. It tells you there's an error on the design. This is why, because you've removed an event handler manually. I'm just going to check this out. 57%. All right, we're not going to have it. This is not going to happen today. All right, and this talks about how to create a simple calculator with operator 1 and operator 2. We're not going to do it this way. We're going to do it more complex for you. Let's go to the second PowerPoint. So I got two PowerPoints. One is for methods and event handlers, and the other one is, and I got to talk about methods in a little bit more detail in a second. So we can do that way as well. So if I go into the second PowerPoint, here it is, because I got to cover this one as well. It talks about data validation techniques. Okay, so that's the couple parts that we want to talk about here for this one is how do we validate data, and what happens when we get errors happen, like unhandled exceptions. Like for example, when we divided by 0 that one time, we use the try catch, right? So that's what this PowerPoint goes over. How do I do a try catch? And it talks about the whole exception handling namespace. Bring this up a little bit more, right? So example would be if I have two types of exceptions. I have a divide by 0 exception, right? Or I have an overflow exception. And an overflow exception can happen when? Come on, you computer science people. How do I get an overflow? Yes. Number's too big, right? But what do you mean by number too big? Like my real number, probably, right? My doubles. I'm putting a float, and I'm putting too many numbers in my float, as an example, right? Or the integer goes number, the high. What's the biggest integer you can have, right, on our machines today? Do you guys know? Is it? It's actually 2 to the 31, right? And then why is it 2 to the 31 if it's a 32-bit int, right? Because one 1 is for negative. So what's the negative? Is it a 1 or a 0? It's a 1, right? Which is kind of it's counterintuitive, because you're like, hey, 1 should be positive and 0 should be negative. But actually what you're saying is, my default, everything is positive, and is it negative? Is it negative? Yes, it's true. That's why it's 1 in the beginning, right? So I have a 31 bits reserved for the actual number, and 1 bit if it's a signed int. 1 bit is for the sign. If it's an unsigned int, it's actually double the size, right? I can have twice the size if it's only positive, an unsigned int, right? So that's the largest integer, positive integer I can have, right? What if I go over that number? Then I'm going to get an overflow error, because my machine can't handle that. Like, do I have an int 64? Does that exist? I don't think so either. It doesn't exist, right? However, I can represent larger numbers with a double, right? And the way we do that is because now, if I have a 32-bit double, right? 32 bits for a double. And if I take away one of the signs, there's 2 parts. There's the mantissa, right? Then there's the exponent piece. The exponent has 2 bits reserved for the exponent. And I have approximately 1 bit that's reserved for the sign of the exponent, positive or negative, right? So I have that piece. But with exponents, I can make my number very, very large, because I can use the exponent representation to make my number larger and larger with some error, right? The larger you go with floating point numbers, right, the more error there is the bigger you go. But the smaller the floating point number is, the more precise it is, actually, double precision, right? Which is kind of a weird thing. So computers, we try and represent numbers, real numbers, as accurately as possible, but sometimes we get this overflow error. What else can I get? A long int. So double size of this 64 long. Yeah, that's the way. But there is no int. There is no int 64. It's just called long. Yeah, they call it long. So, but again, it's double long, right? So for long integers, whole numbers, right? Okay, so we get overflow. Can we get some kind of other kind of thing? Well, yes, we can get divide by 0. Can we get an underflow of some kind? Is there another one that's like instead of an overflow, it's the other way around? There is. If you try and go, it's not an overflow. If you go to, if you put too much precision, it'll be truncated. It's not an exception, but it'll cut off your details. Okay, but that's not really an exception. So these are very common exceptions. What type of exception are they? They're arithmetic exceptions, right? But it's still an exception. So the exception object itself will catch arithmetic exceptions or format exceptions, right? And you can be specific and to find out what kind of exception you got, right? If you specifically say I'm listening for an overflow exception, or I'm listening for a divide by 0 exception. And what does this allow us to do? It allows us to give different kinds of feedback to the user, right? Depending on what kind of error they're generating, right? So an example is if they divide by 0, you can say, division by 0 not allowed. Just putting it out there, right? And then, please put in valid values or whatever. It's, you kind of more of a detailed exception. Or you can also return an exception code, depending if you want to do that. But the exception system does have a series of other kinds of exceptions, and you can be as specific with your exception message as you want. So this is what they ask you to do. We can convert from one type to the other, and I've already handled this with you guys. Like, I think it was like class 1. We did this, right? That's why I'm not really going to go into it. But again, very common ways of converting to decimal, converting to N32, converting. If I want to parse decimal, right? It's very similar to converting to decimal. But again, the 2 types of potential exceptions they could give you the exceptions here are either a format exception or an overflow exception, right? Date time is normally a format exception because we get the wrong format, right? Okay. So we're talking about errors that can happen. Now here's one thing. We talked about some debugging techniques and message boxes, right? For the client, for the user, we want to use message boxes only rarely, right? Rarely, because message boxes are a pain in the ass, right? If you ever go and use an application, a message box pops up every single time you use it, it's really an interruption in your workflow, right? So you got to use it really sparingly, and if it's really important. Example, I'm going to delete my computer, right? Use a message box, right? Make sure you interrupt me if I'm going to delete all my my entire hard drive, please, right? That makes sense. But if I'm gonna, you know, if I'm gonna close down my application and lose all my data, right? That kind of thing. Warn me with an exception, please. Give me some kind of message box that comes up and says, hey, Tom, you're gonna lose your data. Hey, Tom, I'm gonna reset your computer and upgrade, right? I'm gonna update your machine, Tom, right? Please let me know, right? So it interrupts my workflow because I should listen if I'm smart. I wasn't very smart today, right? But it happens, right? So this is where it's a good idea to use these buttons. But otherwise, it's a pain in the ass for users when this comes up, right? Even imagine the web. We used to use alerts all the time in JavaScript. No, hell no. We don't want to use alerts at all in JavaScript. It's a very bad form, right? I would rather use, especially for debugging, I want to use our console for debugging. And we can do that with debug.log here. I've shown you that a couple of times. But for some things, message boxes can be very interesting, especially if you want to get information from users. You can use a prompt type box if you really want to get to simple information. I don't recommend it. In fact, if you're going to use something like this, make a custom form. That's what I recommend. So if you need something from a user, don't use a message box. Use a custom form that looks like a message box, but actually is a form, a full-fledged form with a class behind it. Message boxes are modal. Typically, that means they interrupt your flow. There's also modeless, which allows you to have a box that comes up, but you can keep working, right? And sometimes those are more effective, right, than a modal form. Okay, here's your try catch. We've talked about this before in a lot of detail. I'm not going to go over it, but the default is if you don't specify what exception you're catching, you catch everything, all exceptions, right? So you can do it like this by default. Try catch. I'm going to move on. So when you do a try statement, here's your statements for you're going to try. You can also kind of zero in on the exception class you want. I used just exception, and if you go back to that namespace, you can use the exception container itself to basically specify that I want to capture all exceptions, and you can create an object, right, based on that exception called whatever the exception is. Some people just use E. I don't recommend that. I think you should use exception or some other kind of name, right? And then what you can use is the method or the message property of the exception to tell me the exact exception that comes through. All right? Those are the two properties. One is message, the other one is stack trace. Message is more common by far. And here's an example of that. So I have my exception, my object is X, and I say X.message. Show me this message in a message box. Again, you can do this, but should you do it? No. Please don't give me a message like this, right? Show me a message somewhere else. Show me a message in my form. Make room for your exception in my format. And please do not kill my layout. So make room for the layout. Don't make it so that the layout pushes down an input box and so it snaps back up when it's gone. I don't want that. It's very ugly. Make sure that your exceptions and your errors don't break your layout, right? It's bad form. I'll skip this one. Here's an example of a couple of a more complete try catch. We have a try, and you want to type this most specific exception. You want to go the next most specific exception, then you go the least specific exception. You can do this. So, for example, if I'm looking for something like a format exception, I want to put that up here. Maybe I want to do another one that just says exception. That would be least specific. And then sometimes we also include a finally. So, do this, try this. If it works, that's good, and then finally do this. So do this first. If you don't get an exception, then do this. This is neat because it allows you to break up your try-catch into two parts, part 1 and part 2. A lot of people say that you should include a finally by default, right? So always include a finally, right? So have a try, have a catch, and a finally, even if the finally is empty, right? So that way you can put stuff in if you want to do some debugging. An example of this would be, I want to try, so in the beginning of my try statement, I'm saying trying to, if you're going to do something, I don't know where these bugs are coming from, you're going to try to parse this integer or whatever you want to do, or you want to try and convert the string to double. So that's in your try, and you put that in as in a debug.log, and then you do the operation, and then your catch, you say I'm in the catch statement. I've caught an exception. Here's the exception in your debug.log. It doesn't break your code, but you stop your exception. You might do some feedback on the form itself. And then finally you say, everything's completed, I'm good, kind of thing. Some kind of message says to the user that we've gone through that those steps. And it's a lot of times for testing, we use try, catch, finally, right, for testing cases. Okay, and it gives you an example of that. So here's where we try to do this. Here's a couple of catch statements. So format exception, an overflow exception, and then a general exception to catch everything else we missed, right? And then finally, we perform some cleanup, or let's say do something like release memory back into into the fold. That kind of stuff we do in the finally. Okay. I'm not going to talk about throwing an exception because we're not going to do it by hand, but you could create custom exceptions as well. That's part of it. So I'm going to kind of skip that part because we're not going to talk about it too much, and it's a little bit out of scope. Now here's something that they do. They've kind of included a try catch, and on these next slides you can see that it's broken up into a couple of slides, the code, right? But one thing that's happened is we have inside of our code itself, here's our button calculate click event. And notice we have our try catch right inside this click event. I don't recommend it. I think it's better by far to create your own method that you do your this stuff in, right? And leave this button calculate click event pristine, right? Why? It's easy for me to know what I'm doing, and if I read my code and I say, okay, my calculate button click event, what does it do? It's going to do something else. And maybe there's a couple of operations I'm going to try and do. Some of them may need a try catch block, others may not, right? And I'd rather put it into this whole piece into its own method, right? That's probably better methodology than including all this in the button click event, right? Hey, if this was assignment 1 and you put it all in here and you left it in your button click event, it's okay. I'm not going to take a mark off for form, all right? Remember the first assignment, second assignment, if it works, I'm good, right? I'm not going to go through and look at your stuff so much, right? I'm going to try and break your code. I'm going to try and break your assignment, right? I'm going to try and put some stuff in there, right? So I'm going to try and, remember I talked about validation. So if your form doesn't validate properly, right, I'm going to try and break it. I'm going to try and put some garbage in there, right? So and you should be able to stop me. Okay. Again, another example of that. I'm not going to go too much into that for code handling here. So decimal. This is neat. So I want to check a range of values, right? A range of values, and it's done in a couple of ways. I'm going to say something like this. Here's my my decimal, which is my monthly investment. What it's doing is it's going to convert, right, my monthly investment text box, right, the text value of my text box, it's going to convert it to decimal. Okay, cool. If my monthly investment is less than or equal to 0, then I'm going to pop up some kind of message, hopefully not in a message box, that says, hey, my monthly investment must be greater than 0, some kind of error, right? Else, if my monthly investment is greater than or equal to 1,000, then I'll pop up another box that says monthly investment must be less than 1,000. If I was going to go between 1 and 1,000. Okay.
This is obviously an exception, but why in this case you prefer one prefers using else?
Well, again, it's if, else if. If you notice, if, else if, else if, and you're checking the monthly investment amount, right? And it's going to be a range of values, right? So less than 0 and greater than or equal to 1,000. Why can't I use a switch statement here? Cannot. Remember, switches only test single cases. That's the reason, right? Unless I had every case that I was testing in a switch, but can I test every case between 0 and 1,000? That means I would have 1,000 cases in there, right? And I don't want to use fall through. Fall through is a bad thing in switch statements. Don't do like multiple breaks, or a bunch of cases with only one break. That's bad. Fall through is a negative, right? And what I mean by that is if I have a switch statement, and let's say if I say case 0, and then break, that's okay, because anything inside the case 0 is okay. But what if I have case 0, case 1, case 2, case 3, case 4? I only have one break. It's going to fall through all those cases to the break. That's bad, right? It's bad because negative things can happen, things that I can't control, right? We don't want to use fall through as much as possible. So how come I can do this? The cases are great, or switch statements are great for single values. If I only have a handful of values, switch statement's better than if, else, if, else, if, else. It's more clear. But if I have a range, like a big number range like this, then if, else, if, else, if, else, if is probably the better choice, right? An example of it is it can keep going. If, else, if, else, if, else, if, keep going for different values, right? Here's something that they do though. They actually give focus back to the text box. So the focus method, remember the focus method just brings focus back to that box. But it doesn't highlight everything. It just puts me back in there. And I want to actually, I should also put in the text box, and I want to select all of my text box to show everything. Okay. Okay. Here's what we want to do. What they do in the following a bunch of slides is they create some methods and they call the methods. Okay. Notice that we're passing in an object, the text box object. Hey, again, this text box, is it called by reference or called by value? Come on, guys. I know this is boring because my virtual machine is shutting down, but please tell me what this is. Is this text box here called by reference or called by value? Called by reference because it's an object. A text box is not a double or float or integer or anything like that. It's an object. Objects always call by reference, which means when I, yes? That's a very good question. So the answer is all text boxes, anything in your UI is all string. They're all strings every single time. Actually, it doesn't matter. Like I said before, it doesn't matter if you're programming in Android, iOS, right? If you're making Windows phone applications, any UI, JavaScript, everything in a UI is strings. This is the universal standard, all right? And the reason for that is we can take a string and parse it. And this is the problem. If we're going to get a string, if we're doing our calculator example, this is kind of messed up, right? Do my calculator, and I press the number 1, but the number 1's a string. And I want it to go from right to left. That's another challenge, right? How do I do right to left for numbers, right? So I press number 1, and then I press the number 2, and then I press plus, and then I press the number 1 again, so 12 plus 1. How does it interpret that information, right? How do I want my calculator to work? Right? Because normally my text box is left to right. What I really want to do is I want to right justify my text so it's to the right somehow. So it appears to the right, right justify. But I want it to type from the right to the left. It's almost like writing, in another language, right? Right to left support. So I type a value, and as soon as I type that value, and I type the next one, it goes to the left. It kind of moves this way because that's what calculators do. It kind of works contra to what we're used to. It doesn't go from left to right. It goes right to left. That's the first problem you're gonna have with your calculator. How do I do that, right? Next thing is if I type a bunch of buttons somehow, and I type a big number, right? What if I type a number that's bigger than the calculator window? What happens to the number? Does it go away? Does it get smaller? Like, what do you do with that number, right? Does it stop? But yeah, but I'm saying our calculator is not a scientific calculator. We're making a regular calculator. What happens to the numbers? Like, how many numbers can you type in there, right? It stops, right? Like, calculators stop you from typing any more values, right? And so these are the things consideration. You might think a calculator is easy to do, but it's a pain in the ass, right? To make it to work exactly like you really want, because there's a lot of details in a calculator. Okay, so I got a number like I said, 12, 1, 2, and I click the plus button, and then I click 1. Okay. Well, after I click the plus button, what I'm expecting is when I click 1, the 12 disappears and 1 appears. That's what's going to happen there, right? Where did that 12 go? Where's that 12 being stored, right? It's got to be stored somewhere. So as I'm doing that calculation, I press the plus button. It's storing my first operand somewhere, right? Somewhere in memory. Then I press the plus button, and I put the other number in there. And if I keep typing the number, it's going to keep typing whatever number I want. Let's say I type 1. So 12 plus 1. Okay, now I press equal. If I press the equal button right away, takes the first operand and the second operand and performs the operation I mentioned, plus. So I got to keep track of the operation. What operation am I doing? Plus, right? Which is addition. Okay, what if I do multiple operations? Like I go 12 plus 1 plus 3 plus 5 plus 7 plus 8 plus. How do I keep track of what my number is at, right? A couple ways to do that. One, keep a history of all the operations you've ever done, and then do a calculation after, right? That's one way of doing it. Or calculate as you go, like most calculators. So you press 1 plus 1. If I press equals, it's going to give me the answer, right? Or if I press plus, it'll take the first two, add that, make that the operand, right? The first operand, and add the next one as the second operand, and then forget the, and keep going, right? So many ways of doing it. So you might think it's easy, but you have to keep track of stuff in the background, like a lot of stuff going on in the background in the calculator, especially with things like minus and multiply and divide, because you have to divide by 0. Got to check for all that. Here's another one. What if I press the dot? I want to press a decimal, right? So 1.1, and I press another dot. It should stop you from pressing a second dot. It should detect that one dot's been pressed already, right? Because I can keep doing it. I can put 1.1.1.1.1. It'll take it, right? What are you gonna ask? Will you make sense? These are the things that have a problem. Let's see if I'll check to see while I'm talking and see how much we're done. 86%, right? There we go. We're gonna get there. So, yeah. Which? How do I pass it? Yeah. Yeah. Now the name of the string. So for example, the name, right? Whatever the name is of is present, right? Take a look. Right. Is a required field. Whatever the name of the text box, the name of the object is, you can get that information depending on what you pull in there. We'll see that as an example down here. So is decimal. There's a couple of methods that they describe here. Notice this text box and name. And they're giving you some, these are patterns that they're giving you. And another one is within range. So check within range method. These are kind of neat little methods, by the way, that you can use. If they're in the book, it's okay, right? I'm not going to say don't use the method. Go use it if you want to use something like this. Highly don't recommend a message box, right? Because they're ugly. But if you really want to use this method, yeah. Yeah. Yes, well, this particularly, that's why they've named them this way. It's a Boolean. It's going to return either true or false, right? What? No, no. This is just a naming convention. They called the method. Someone called the method is present.
Oh, it's not a keyword.
No, none of these are key. These are custom methods. All of them are custom methods. So custom method, custom method, custom method, right? These are our custom methods. And then at the end, we want to use it. We want to use them. So here's the way we use them. So is present, right? Text monthly, the monthly investment text box. And then we pass in the name, monthly investment, right? So that's the name, the string name. So we say, well, monthly investment then is required, right? And we do that if it's present or not, if the value is present. That's what we're checking, okay? Not a great use of it. And if you notice, it's like if you're going to check if each one of these, all of these things have to be true. So if it's present and if it's a decimal and if it's within range, then you're good to go, right? Otherwise, you're going to get an error. That's what this is doing. This is a great way of doing troubleshooting and checking a number that's a specific type. Is it within range? All that kind of stuff is right here. Not bad. Not a bad idea. Without using validators. Okay, that's a totally different thing. Okay, so it gives you some ideas about how to do that, right? And it goes into more detail here. Let's do another exercise. So again, if I was gonna do and I want to try this stuff out a little bit. So we talked about methods today, right? And I want you to pull up your Visual Studio. I want you to create. No, I love this. Am I still recording, by the way, or did it drop me again? Yay, I'm still recording. I'm going to use Xamarin Studio here. So I'm going to go Xamarin, right? And you can use Visual Studio for yours, right? Because I don't want to kill my installation. So bear with me. Bring up Visual Studio if you have it. I want to make a little console application with Visual Studio, right? Or Xamarin Studio. And the way we do with Xamarin Studio, if you have it with your Mac, you can go New Solution, right? And notice that I can use a new ASP.NET, a .NET application, right? Or another. Also, I can build iOS apps, Android apps, Mac apps, and so on, right? So if I click .NET, I can choose a console project, a library, an empty project, or other kinds of things, right? Miscellaneous will allow me to make a blank solution, a workspace, or a generic project, right? I want to make a console application, though, and I want to make sure it's C#, okay? And I'm going to click Next. Now, for you, you'd go File, New Project, C# Console Application. That's what you're going to do in Visual Studio. I can't show you that, but you can do that. Click Next. My project name, might as well do it, COMP1004, and I'll say Fall 2016, and we'll say Lesson 4B. We'll do the A after I'm up and running, right? And I was going to show you this anyway. I just didn't expect to get to here. I'm going to use a Git for version control and a Git ignore file, no problem. I'll put it up later on. I'm going to click Create. It's going to go on Thomas Project. Sure, it doesn't matter. Oh yeah, that's good. I like it. It doesn't like my project name in this particular case because my project should have underscores because I'm on a Mac. All right, let's try this again. Great. There we go. Okay, here's my class. So my class is my main class. You can also call it my program. Here's my main class, right? And here's my console.writeLine. Here's my hello world. And if I was to run this thing, so if I click run, just to show you that it works, bam, it's just hello world, right? Done. So it runs C# on a Mac. Xamarin Studio is great like this. And I highly recommend it for Mac users because if you want to run C# or anything like that, it's good. And if you want to do cross-platform application development for both iOS and Android, and you want to do it only in C# and not in Java or Swift, Xamarin's for you. But I can use it sometimes for testing. So here's what I'm talking about. If I do a method, and I need to do a method that's in this class, right? Now here's a question for you. This public static void main is a static class. I want to do a static utility method, so I need to do the same thing. So I can go public static, and I want it to return void, and I want to do something like, get name method. Okay, here's my get name method. It's going to return void, and here's my public static get name method. This is one signature. Don't worry about what's inside my curly braces. But what can I do this too? Let's make another method. Public static void get name, same method name, but instead of doing that, I want to say inside my parameters, I want to pass in something that I want to pass into it. Like I want to get the name, but I want to pass something in, like for example, current name. So current name, right, which is going to be a string type. There we go, current name. And I do this. And what is this? How do you deal with this? Well, in C#, this would be called, I'm going to bring this down a little bit so you can see it. In C#, this would be called overloaded methods, right? So I want you to think about this as, how can we do this? Because I have what I have is I have two values, two signatures, one signature that's empty, and the other signature that has a string parameter. Those two method signatures, as well as the return types, right, make these two methods unique. So I can have both methods with the same name, get name, one that takes a string and the other one that takes nothing. Okay, exactly the same. I want to talk about it so that way you know it's legal in C#. In fact, most things in Java pretty much will work in C#. You just need to convert some of the syntax. For example, some of the variable type, the data types and so on, you need to convert those. The way we do classes a little bit differently. Those kind of things. Oh my God, I got Windows back. I can actually do my stuff. Let's see if I actually have my little application, right? What was that? To me, I wonder if it's going to work now. Yes, it is almost exactly the same. And remember that, oh yeah, I love this. Definitely, for sure, 100%, I'll say it twice, right? My application that I was building with Visual Studio, it's gone, right? I got to definitely download. I'm going to use yours again, right? Don't turn off my PC. Let's see you later. The question is, what's the difference? There's not a lot of difference in terms of syntax, very little difference, but the back end is where the difference happens. Remember the C#, because especially with when we're using Visual Studio and on the Windows system, uses the .NET framework, and the .NET framework has the common language runtime, which is a lot different than Java, right? So if I was to program C# or VB or C++ in Visual Studio, all the data types are the same, right? Not so Java is its own thing. It's not part of the Java, the common language runtime. But in terms of operation, the way it works, for the most part, it's the same, right? However, Java does some stuff that's a little bit different in terms of things like anonymous inner classes. C# doesn't handle anonymous inner classes the same way, right? In fact, doesn't handle them very much. It doesn't like to use them at all. And it does a lot of other things when it comes to, there's a lot of libraries that exist on C# that don't exist on Java. So a lot of the language differences are the libraries that exist as well, right? Like for example, oh, I think we're good. Ha! A lot of the stuff that I can do in C#, as an example, are based on the libraries that I access. Let's see if this actually works or if it probably killed me, right? I fully expect the application we're building to be kaput, by the way. But we'll see what happens. We only have 20 minutes, so for me to finish off my application in 20 minutes is just going to be absolutely impossible. But we went through the PowerPoint, so I kind of handled exception handling and the stuff that we talked about before. I do have a video that I have up in another course that I've done that does the calculator, right? But what I'm going to do is, just to make up for this technical difficulty that obviously is my fault, what I'll do is I'll put together maybe another video, right, to build the calculator for you guys, right? It won't be today, and it'll have to be you watching it without me doing it, but you'll have the bit of the calculator that I'm going to build. I'm going to build it out for you from scratch again, right?
We all get 10 bonus points.
No, but I'll build it out. And the reason why I want you to know how to do this stuff with the calculator, and what I'll do right now is, I'll see how it goes. It's probably dead, because when it resets the thing, it doesn't save anything. Like it wouldn't if Microsoft was smart. If I'm going to do an update, it just saves everything and closes everything down. That's what it should have done. And I'm hoping that's what it did, but I don't think it's that smart. I think it just like will reset everything. Yeah. Ooh, it is smart, right? Recover selected files. Yeah, I think I want to do that for sure. Yes, yes, yes. But it doesn't mean that I'll have my UI, because I was kind of in the middle of things, right, when that happened, right? So, all right, let's just check this out and see what happens, because that would be very awesome if we were allowed to do that kind of thing, right? Like if my calculator form itself, right, would actually work, that'd be awesome. That'd be fantastic. But I don't expect my calculator form to work at all. And I'd be very impressed, Microsoft, if you're watching, right? Microsoft doesn't care if I'm impressed. Let's take a look. If Microsoft is good, guys, hey, no loss except for time that we lost on dealing with stuff we already know. All right, so I got my buttons. This is a good thing. I'm assuming. Let's make some assumptions here before we go on. I'm assuming that nothing is broken here. All right, on my application. Let's put this up on GitHub. All right, so I'm going to go to my Team Explorer, right? That's what happens when you mess up GitHub. I'm going to go to changes, and you can see that I've got a bunch of stuff going on with the changes. My form designer has been changed. This is bad. Look how it's been destroyed. Form 1 designer. And I'm going to say something like added buttons or basic buttons. I'll say basic buttons to my UI. Okay. And I'll go home, and I'll go sync. And of course, we don't have a remote that's been created. So I'll create my remote. There we go. I'm going to click from me to Georgian, right? And the repository is going to be COMP1004 Fall 2016 Lesson 4. Let's do this. It's good. I'm very surprised and elated that Microsoft has saved the day. Microsoft, I want free services for here. No, I'm joking. Because I'm pumping Microsoft. But one good thing is that the SSD made the update a little quicker. Okay, let's test this thing to make sure it isn't broken. So I'm just going to run this thing for the first time. You have the GitHub repos already there. So if you didn't do what I did, then you should have a the GitHub repo should be able to save you. And let's see if I have a problem. Okay, so I have my buttons, but as you can see, they don't do anything right now. And what I talked about before, I'm going to leave these buttons blank for now, please. So let's leave these buttons so they don't do anything. Just placeholder buttons. Okay. What I want to do is I need to create an area that's the result area, some kind of result or display, whatever you want to call it, and I can use another tool for that. What tool should I use to display my data? My recommendation is a text box of some kind, right? So I can do that. Let's put the text box in place. So again, it's a standard tool. So, and remember, I've already set the form default to a certain size. So here's my text box. And I can make my text box as big as I like, but now normally you see the text box a little bigger, yes?
How bad would it be?
It's not bad, but the thing is, the problem is it might not look right. It's not bad. You can use a label. Label will give you some flexibility, right? But the problem with a label is you would have to, actually the same thing. The string would be the same. You build a string. I'm going to make my text box the same length, so it's going to be the kind of the length of the calculator. And I want to tighten up this so that there's less room on my form. So I'm going to kind of push this up. But I want to move this whole box here, this whole thing, up a little bit. And I want to kind of latch on to this thing. what it requires is for me to go from a programming perspective. I want to go up to my lock area where it says lock and unlock it. So false. Now what I want to do is I want to move this whole thing. Oops. I want to move my whole thing up, right? So this whole control. And notice there's a little control to do that up here, where I move it up, right, where I want it. I'll move this up to the top because I don't want extra room on my control. Now all I'm doing is clicking over here. When I click on my grid itself, you can move the whole grid up because it's kind of a layout, right? And I'll move it up to here. Good. Now I want to kind of reduce the size of my calculator so it looks like this. Now, is it a pretty calculator? Hell no. I know it's not, right? But it gives me all the functionality that I want, right? Let's check this out. I want to create my first event. Now this is going to be, first of all, I need to make this call this a result text box or something like that, right? So here, when I click on the result text box, I want to go up here, and we'll call this result text box. That's the name of the text box itself, right? Not the name of my layout. This text box here has got to be result text box or something else like that. Result text box. There we go. I don't want anything in there, or do I? What does the calculator show when it first turns on? 0. So I didn't want to put that in there. So let's put that in there. Boop. Now it's not going to be over here, because if it's over here, it's not going to act like a regular calculator, right? We want it so it comes over here, right? That's where you want it to be. Now remember, the text align is left. I could do text align right, but this isn't going to solve my problem, right? Because it's going to kind of go left, so it's going to go this way when it prints out. Let me show you this. If I go 0, 1, I press enter, this is what it's going to look like, right? It's going to type from that side, which is good. I'm just pointing it out to you that there might be some issues. So for now, it's 0. We're going to talk about it. Here's the next piece. The next piece is when I double click on my 1. I'm going to start with my 1 button. Okay, so double click on my 1 button. Strategies to make this work, right? Remember what I talked about. I want to rename my event handler. Right now it's called 1 button click. That doesn't make any sense. I want to call it, you know, calculator button click. That's what makes sense. So I'm going to rename this thing. So I'm going to right click, right, and rename, not by hand, but by using my rename, my refactoring, right? I'm going to just call this calculator button. Oops, if I can type it, button underscore click. Now you can call it whatever you want. I'm just using the underscore click because that's the methodology that they use. Cool. Calculator button click. Yay. Huh? Right click. So I kind of highlight it, right click, and I go rename. Okay. Okay, so now that I've got that done, I want to point all my buttons there. So I just want to put my 1 button, but I also my 2 button, my 3 button, all these buttons. Can I somehow point them all by control clicking? Can I control or manage to click more than 1 control like this, right? And have all those buttons along with all these buttons, right? This is my button, my calculator button. These are all the buttons. I've already done my 1. I want all these buttons to point to the same control, right? How do I do that? Click on the lightning bolt, and where it says click, pull down the 1 event that I made. And that changes all the buttons click events all at once. So I don't have to go this one, that one, this one. It takes too long, right? This is a much faster way of doing it. Okay, what now? How do I differentiate between which button is being clicked? Let me save this one. Yes.
Just by writing the name of the button, making amendments with each other.
Well, first of all, let's take a look at the actual calculate form itself. So here's my calculate form. I have 1 button. Remember that I have the sender. I talked about this last time, and I have the event, right? It's the click event. So what I want to do is I want to create the button type, right? So my sender, I want to create a button, a temporary button. So here I'm going to use button, right? And I'm going to call this the calculator button. That's the calculator button. We don't have a calculator button. We have a 1 button, a 2 button, 3 button. We don't have a calculator button. And what I want to say is it's equal to the sender object cast as a button. Very good. We have the button. All right. Does that make sense? So I'm getting the button from the sender object, whatever I clicked on, but I'm casting it as a button, right? So I'm because my sender object can be anything, and if I want to get code hinting from my sender object, right, which is now my calculator button, right, then because I should be able to do something like this with my calculator button. Let me just take a look and see this. So calculator button dot and my text, whatever I can test for that, right? So depending on what my text is, you know, for my calculator button, that's one. How about the ID, calculator button dot ID or name? Can I check for that? And the answer is yes, I can, right? So if I can check for the name of my calculator button, depending on what the name is, I can do an operation, right? Here's the first thing I want to do with my buttons. When I click the button, for now, I want to show it in the result, right? The result text box. How do I do that? I do something like this, right? I can say something like this. I can say something like result text box dot text is equal to my calculator button, whatever it is, calculator button, right? Dot name, right? Because my calculator button dot name is a text object, right? Let's see what that happens if I do that. So calculator the text equals whatever the name is of the calculator button. Remember, I named my calculator buttons 1, 2, 3, 4, 5, 6, 7, right? I did that. What if I just said, instead of this, I said text? Because my text shows a 0, 1, 2, 3, 4, 5, 6, 7, 8, whatever it is, right? Let's try this. So no, there's no switch statement here. It's just going to, whatever the result is, whatever I type, it's going to go to my result text box. Let's see if that works. Yeah. Calculator button is a reference to it's got the shape of the button class, right? That's what it is. In the beginning, it has no, it's not an object. Here, when I make it point to this other object, when I have one object, when I pass one object to the other, I can't pass by value, I'm passing by reference. So when I use the equality operator equals, I'm actually creating a reference to the other object. So I'm actually pointing at that object. So now my calculator button represents that object that I've clicked every time I click it. So if I click another button, now the reference has changed. Third button, reference changed again. And it keeps changing the reference of my button depending on what I clicked, right? Which means it's very flexible. I don't have to use a switch statement at all. I know which button I'm clicking. I may have to leave you with this. I know people are having to go, and I do apologize. But let's try this at least for our calculator. Maybe we'll continue our calculator example next week. So here's an example. I click 7, and I get 7. What about if I click 8? I get 8. It replaces. If I click 9, 6, minus, divide. I can do all this. How about this button? I don't get nothing here, right? Because it doesn't have any value. Therefore, it doesn't change this. And I don't have an event that's tied into these little buttons. Therefore, it doesn't do anything, right? The sender goes on to, now that I've got this, right? And I can identify which button I'm clicking, we're halfway there, right? Halfway there. Now I can do detection, all right? For example, I can check if an operator is being clicked. And if an operator is being clicked, what am I doing? For example, can I start clicking the operator after I have my 0? So for example, and if I click the clear button, what does it do? It's not going to click the clear button, right? That's where I can do my switch. I can say if it's a clear button, right? If the calculator button dot text is equal to clear, the C, right? Then go back to 0. So redo the text in the result text box to 0. Let's do that one first, right? So if I go back to my calculator button, right? Result text box dot text is equal to the calculator button dot text. I could do that, but what I really want to do is do a switch statement here, right? And I can, in the switch statement, I can say, well, depending on what my calculator button dot text is, because it's going to be one value, right? I want to do the following things, okay? And I'm going to call different methods in my switch statement. Each button is going to produce something, some kind of method, right? For example, if it's some kind of a value between 0, 1, 2, 3, or whatever it's going to be, I know it's a button. I'm adding a value, right? Depending if it's a button. So I only want to check those ones in the switch statement, right? I want to assume that the number that I'm going to get in my switch statement is always going to be a number, because most often there's more numbers on my calculator than operators, right? So those are the ones. So where can I put that case? The default case. The default case will be the number, right? That I'm getting, whatever the number is, right? Okay, so if I do something like, so here's my switch statement, and if I go case, the cases that I want is if the case is a clear, then what do I want to do? I want to do something in the clear statement. I want to say that my result text box dot text, right, is equal to 0. That's what it's going to be. It's going to clear the text box, right? So if I click anything, if I click my clear button, the result text box dot text is equal to 0. All right, that's an easy one. How about in the case where my the result is a plus? What do I want to do? And I want to leave you with this because we're going to talk about this. I'm going to put some pseudocode in here. We're going to say call the addition method, right? That's what we're going to do here, right? I'm going to say a break, right? And if my case, in the case that it's a minus, right? And what do I want to do, right? I want to call, here's my pseudocode, call the minus or subtraction method, That's what I want to do here. So I'm calling different methods from within my calculator button click event, right? And you get what I'm doing with this thing. I'm going to keep on going with this example, but I want you to I want you to think about this. I want you to, if you want to do some practice homework, I'm not going to make it a lab because to make it a lab, a lot of you may not be able to do it. I'll be honest with you, right? Because there's some tricky stuff around this thing, right? But I want you to challenge yourself if you've got time, all right? Because I'm asking you to also start, assignment number 2, right? If you've got time and you want to practice, finish the calculator, all right? Make it work for yourself. And if you can do the calculator, I guarantee anything else I ask you to do in this course, you'll be able to do. It sounds crazy, but the calculator is actually quite complex. If you want a further challenge, an advanced challenge, make it scientific with a proper output, right? You think it's easy, but it's actually quite complex to do, scientific calculator, right? And as a further challenge, if you really want to make it crazy, change the mode. So have a radio button that changes the mode from standard to scientific. So the layout will change. If you really want to go crazy.
I have one question.
Yes.
What about
Yeah. There's so much stuff in there. Right? Calculator's huge. Calculator's massive. Guys, thank you so much for watching today. I know we didn't cover as much as I wanted to, but I want you to take the one thing I want you to take away is that shared event handler that I just did, and the ability for you to have multiple buttons hit one event handler, because we're going to do that a lot coming up in the next several weeks. Okay? At least we got that part done. Yes.